What we're going to do today is look at representing patterns. But I'll give you a hint, they're not just any old pattern, they're specific patterns. It's called linear, which we'll talk about in a second, and that's what this whole unit is on, is something called linear equations or a linear relation. So let's just imagine I gave you these blocks in figure 1 and figure 2 and figure 3, and then you'll notice there's a little dot, dot, dot. What does the dot, dot, dot means? Yeah, it means it keeps going forever and ever. So there would be a figure 4, a figure 5, figure 6, etc. I've only shown you the first 3. I just want you to turn and talk for 30 seconds. Talk about what the pattern is, what's happening from figure to figure. Okay, focus back. I'm grabbing a highlighter if you want to grab one with me. So if we look at the 4 blocks in figure 1 and we look at the same 4 blocks in figure 2, what have we added? Well, we've added the 2 on the top and the 1 on the right-hand side. That's really what's different between figure 1 and figure 2. If we think of figure 2 in terms of these 2 columns of 3 and this column of 1, well, that's on the right-hand side here in figure 3. What did we add? We added these guys here. So that's really what's different, is that first column. It doesn't matter where we add the extra blocks. The point is, how many extra blocks are we adding each time? Well, if we think of this in terms of numbers, there's 4 blocks in the first. Then there are 7. Then there are 10. How many would be in the next figure? 13, and then 16, and then... So what's the pattern? How do we describe this in words? We are adding 3 fishes, $3, 3 cats. I want to call them blocks just because of what I already called them, but you can call them squares. So when the question says describe the patterns in the world, that's all they're looking for. In words, what are we doing to go from one figure to the next? And it's not always going to be blocks. You stay, I'll turn. The next one, circles. And then if we look at example 3, oh my God, words, what's going on there? Okay, so it's not always going to be blocks. But the point is, you're just trying to figure out is what did we add to each one. We're going to create a table of values to represent the pattern. What's a table of values? I love when I ask you these math questions because you've been doing it for years, but you can't explain it. It's like a thing with a thing. Like a T-chart, that's a great synonym. I've heard that before. It's going to have something to do with the number of blocks and the figure number. Does a table of values go lengthwise? So is it vertical or does it go horizontally? Does it matter? No, it's completely up to you. I tend to do horizontal so it doesn't take up as much space. But if you're a vertical thinker and you want to do vertically, whatever you want. So again, I'm going to do horizontal, so I'm doing my T kind of this way. The top is going to be the figure number. The bottom is going to be number of blocks, number of squares, whatever you want to call them. Again, if you're a vertical thinker, you can do it vertically, completely up to you. So let's do, I don't know, the first 6. The first figure, how many blocks? Second figure? Third figure? Okay, that was from counting. Now we're just adding on the pattern to figure out. We already talked. The next one would have 13 because we're adding 3 every time. And then 16, and then 19. So when the question says create a table of values to represent the pattern, that's all they're looking for. Okay, typically it's number or figure number and then number of whatever, blocks, circles, whatever we're adding every single time. Write a linear equation to represent this pattern. So here's the big picture of math. Why do we have math? Well, really, it's to be able to figure stuff out in the world. So math itself isn't really the tool. Math is the tool for scientists to figure stuff out, and chemists, and biologists, and economics. It's what people use to figure out stuff around them every single day. So in the world, what we're always looking for is patterns. That's how we're eventually going to find the cure for cancer. It's how we figured out different things. It's looking at patterns in the world. So if you think of math in the general sense, it's really just analyzing patterns. Why do patterns exist? What do they mean? How can we do with them? So what we're doing now in high school is we're starting to introduce you to different kinds of patterns. And what we're going to do over the next 4 years is introduce you to a whole bunch of different kinds of patterns. If you take pre-cal, it will be one set of patterns that you need in pre-cal. If you take applied, it will be a different set of patterns. If you take essentials, it'll be more patterns you're going to use in trades. So that's really what math is about patterns. And so we're starting with the very, very basic pattern in grade 9, and we're going to talk about what's called linear patterns. What does linear mean? What does the word linear mean? Does anyone know a synonym for the word linear? It means a line. So it means if we were to graph this function, or this equation we call it, it would look like a line. That's it. That's all we're going to do in grade 9 is just look at stuff that are linear, stuff that looks like lines. Next year, depending which one you go into, you'll look at different kinds of patterns. If you go pre-cal applied, we'll start looking at things called quadratics. Doesn't that kind of sound exciting? A little bit. All we're going to focus on is lines this year. So that's all you need to understand, is that this is eventually going to deal with linear equations, which are solving things that are lines. Now, everybody in the world has things that bug them. Mine, well, I have a few. When you touch my stuff without asking, we've talked about that. It bothers me as a mathematician when people say straight line. Because what's a not straight line? It's a curve. So can you have a line that's not straight? No, so please don't say straight line. It just bugs me. A line is a line. Straight line, no, you don't need to say straight line. Here's how you're going to write a general linear equation. It's going to end up looking something like this, and I don't want these letters to scare you. So if you go into pre-cal applied, you're going to see this again next year. If you're going into essentials, this will vanish from your world, and that's okay, because you're going to call it something different in essentials. But this is what's kind of coming down if you're going applied pre-cal. Y is always going to be the amount of items. So whether it's blocks, whether it's circles, whether it's chairs, whether it's people, it's always going to be the amount of items. So in this case, I'm going to use a variable. I'm going to use B. What do you think B represents? Blocks. Because mathematicians were really obvious people. B means blocks. If this was talking about circles, guess what I might use? C. If it was people. So don't get caught up in the variables. Variables, as we talked about in Unit 2, are just representing an unknown. X, I'm going to come back to M. X is always going to be the figure number. Okay? X is always going to be the figure number. So give me a letter that might represent figure number that's better than X. F. So I'm going to put an F there. Again, don't get caught up in what the variables mean. They're just variables. I'm going to highlight M and B because those are going to be numbers. And the way this is always going to work, there's no exceptions to this rule, is the M, so the coefficient of F, is whatever the number of objects you're adding from figure to figure. The M, or what the coefficient of F is going to be, is always the number of objects you're adding from figure to figure. What are we adding in this question? 3. So for this equation, it's going to be 3. Are you still with me? The B value, which again, don't get caught up in the variables. This is going to mean more next year. The B is what we have to do in order to get these numbers. So follow the logic here with me. Here this is saying I need to take the figure number and times by 3. That's what an equation is, a set of rules. And it's saying take the figure number and multiply by 3. So if I take 1 times 3, what do I get? 3. Except the number I have here is 4. So what do I add to get 3 plus something equals 4? 1. Okay? Follow me again on that one. Well, let's check 2. If I do 2 times 3, what does that give me? What do I need to add to get 7? Oh, it's 1 again. 3 times 3 is? What do I need to add to get 10? 1. 4 times 3 is? 12, except I need 13, so I need to add 1. That's a linear equation. They're going to always work this way. Let's add some notes for the wordy people. This I'm going to call the number of objects. In the grand reality of math, it doesn't matter if I call it B, if I call it Y, if I called it Q, it doesn't matter, it's just a variable. Typically, we go with what the object is. It's blocks, I use blocks. The F is going to be the figure number. Again, don't get too caught up in the variable. It can stay as X, it can be F, it doesn't matter, it's just a variable. The coefficient of F is always going to be the number of objects added. And that's really just the pattern. That's why we did A first, so we could analyze and say, well, what is the pattern? And A leads us to know that it's 3. The reason we did the table is just to have a way to get this last number here. And this is what we add. To get the values in the second, now row if you're going horizontally, column if you're going vertically. So what we add to get the numbers in the second row. I'm just going to put an arrow pointing to those numbers. They're always, always, always going to work this way. You're going to start with a variable on the left. You're going to have 2 numbers you need to fill in on the right. The first number is going to be whatever the pattern is. The second number, or the last number, is whatever you need to do in order to get that second row. So let's just review, why was it 1? Well, if I have 1 times 3, that should be 3, but it's not, it's 4. So how do I get 4? I add 1. And then we can check, well, what's 2 times 3? 6, but I need 7. How do I go from 6 to 7? I add 1. We can even check a number way down here. What's 6 times 3? 18. What do I need to do to get 19? I need to add 1. This is called the linear equation, linear relation, linear function. I'm going to repeat all those words because they all mean the same thing mathematically. Linear equation, linear function, linear relation. And in grade 10 pre-cal, you'll find out, well, what's the difference between those words? We'll figure it out then. For now, in your world, they all mean the same thing. Linear equation, linear function, linear relation. Hello. Well, why do we need to know this? Why do we need this linear equation? Why does it matter? We'll take a look at number D. Number D, that's right, number D. So we could keep going this pattern, and we could go all the way up to 12, but why would we do that when we can have an equation to do it, Cam? Hi. What if I asked you the 100th figure? Are you going to want to fill in the table all the way to 100? No, that's what this equation is for. It's for to be able to quickly calculate how many blocks we need down the road in the pattern. So letter D is asking for figure 12, so that's telling us that F equals 12. So all I'm going to do is take my linear equation, and I'm going to say B equals 3 times 12 plus 1. That's the whole point of the equation, is to be able to quickly calculate the number of blocks we need in the 12th figure without having to write them all out. Bed mass, what do we do first? Brackets, okay, inside the brackets, is there anything I can simplify? Okay, what comes after B? Exponent, any exponents? Nope, what comes after E? Multiplying, so we're going to do this multiplication first. 3 times 12. And the last thing is the addition, so 36 plus 1, 37. How many squares or blocks or objects in the 12th figure? 37. That's the point of this equation, is to be able to look at patterns and predict what's going to happen in the future without having to do all the work in between. Who are the lazy mathematicians, let's be honest, who hate showing work? This equation's for you guys, because you don't have to do all the work. You don't have to write it all out. You don't have to write out the table for 100 different calculations. It's just a quick way to do it. Well, we can also use the equation to go backwards. So E wants to know which figure would have 106 squares or blocks. which figure would have 106 squares or blocks? So what I'm going to do this time is put the b in, which they've told us is 106. Okay, this is from last year, and this is what the middle part of our unit is going to be, is solving these equations. So let's go back to grade 8 in our head. How do we solve an equation? What we do is we pick away at it. We do the opposite of what's already been done. So the opposite of adding is? Good. Opposite of subtraction? Opposite of division? Opposite of multiplying? Good. So I'm going to start with this plus 1. What's the opposite of adding 1? How do I get rid of it? I subtract 1. And if I do it to one side, I got to do it to the other side to balance it out. So what's 106? 106 minus 1? 105. Now we have a coefficient, and we know that this means multiplication. Even though there's no symbol there, when there's two things stuck together, we know it's multiply. So what's the opposite of multiplying by 3? Cam, second time. What is Uriel doing that is so exciting back there? And smiling and laughing at him. Are you done? Okay. Oh, wait. Okay, we're good? Do you want me to come scratch it for you? I will. I know it would be weird. So this is multiplication. What's the opposite of multiplying? Divide. Now you have two choices. You can write divide by 3 like that on the side, or mathematicians, we do it underneath. So if underneath freaks you out, then do it on the side if you want to. It doesn't matter. This would be a calc question, so grab a calculator. 105 divide by 3. So 105 divided by 3. Offer? 35? Confirmed? Sounds confirmed back there? What did we just find out? What is that 35? What does it mean? That's the figure number that's going to have 106 blocks. How are you feeling so far? Every question is going to be exactly like this. It's just going to change what the objects are and the number. Circles. Turn and talk. Talk to your neighbor, decide what the pattern is. Well, that was quick. Can't fool you guys. What's different between figure 1 and 2? So this guy is new and this guy is new. What's new here in figure 3? The last two on the right. What's new over here? The last two on the right. So what's the pattern? We're always adding 2 more. Write down the pattern in words. You need to have something about the word adding. You need to have something with the number 2, and you have to have something with what kind of objects it is. So something with adding 2 circles. How you choose to explain that is up to you because it's your words. Just turn and talk. Share what you wrote down for A. Riley. Yeah, but you're turning and talking. Okay, table of values. Again, if you want to do it vertically, there's nothing wrong with that. I do it horizontally just to save paper. The top is always going to be the figure number. Bottom is going to be number of circles. So 1, 2, 3, 4, 5. I have room for 6, so let's do 6. Even if you think you can't do math, you can do a table of values because all you're doing is counting. How many circles in the first figure? 1. How many circles in the second figure? Now you know the patterns. You can either add 2 or you can just go back up and count the number of circles. How many circles? 5 followed by 7, 9, 11. So now when the question asks for table of values, that's all it wants you to do is give a table of values. Still with me? Linear equation. It's always got two variables, it's always got two numbers. We start with a variable on the left, and it's something that represents the number of objects. Riley, I'm going to take it if I keep seeing it. Give me a letter that might represent the number of objects. C. What could C represent? Circle. It doesn't matter what you put. You could put Y, you could put P. It doesn't matter. Don't get caught up in the variables. Then I'm going to leave a space for the number we're going to fill in. I'm going to go to the second variable. So I'm going to leave a space and a space for numbers. We'll fill them in a second. Give me a letter that can represent the figure number. F. Some people use N for number. Completely up to you what you use. Now we have the two numbers to fill, and let's talk about the coefficient of F. What does it equal, and where does it come from? It's 2, and Y. Where does that come from? It's the pattern, so we're adding 2 every single time. The last number you need to get from the table of values, and what you do is you start with the multiplication. 2 times 1 is? 2 times 1 is? 2. But I need 1. So what do I do to 2 to get 1? Minus 1. Now let's check it. Let's do a couple more just to check. 2 times 2 is? 4, and I need it to be 3. So does that still work? Yeah. 2 times 3? 6 minus 1? 5. 2 times 4? Minus 1? 7. There's our linear equation. That's the hardest part, is getting the equation. Do you understand where the 2 and the minus 1 has come from? How many circles would the 71st figure have? Well, I don't want to do this table all the way up to 71. I want to be lazy and find an easy way to do it. So what I'm going to do is take out F in the equation and put in 71. Multiplication first or subtraction first? Multiplication first. 2 times 71, do 2 times 7. It's 14, so 2 times 70 would be 140, and then get another times 1. So in total we have 142. And then 142 minus 1. What does that represent? What did we just calculate? Number of circles in the figure 71, because I don't want to do this table all the way to 71. What figure would have 83 circles? What do we do? Yeah, go back to the equation, and instead of replacing F, we're going to replace C, because it says circles, 83 circles. So circle's going to come out, 83 is going to go in, everything else is going to stay. How do I get rid of this minus 1? What's the opposite of subtracting 1? Adding 1. 83 plus 1. Do you already see the patterns like to the last example? How it's exactly the same, just different numbers. How do I get rid of a multiplication by 2? Divide by 2. And again, I write my division underneath. If you want it off to the side, that's fine. F equals, offer 42. What does that mean? It means that there are 83 circles in the 42nd figure. Verify your solution. What that means is go back to the equation, put in your F, and let's make sure that it has 103 circles. So it's just double checking. That's what verify means. What do we do first, multiplication or subtraction? Multiplication. 84. 84 minus 1. Does it have 83 circles? Check. That's what verify your solution means. Show me your thumb. I'm getting this. I'm kind of getting this. I'm not getting this. Good. Let's do the last one. Oh my God, so many words. Read to read. Just read the first part. Don't worry about the ABC. Just read it like it's a paragraph in a book. Don't overthink it. Just get the general context. What's it about? Orchestra and chairs. And that's maybe all you got the first time, and that's okay. Now let's deconstruct it. What's important? Well, it's something about an orchestra seating. What else is important in that first sentence? So I'm just on the first line. There's still something else that's important. Rainbow shape, so it's telling you what the diagram's going to look like. The most inner row is 7. Next row is 12. Third row, 17. Fourth row, 22. Part A is getting you to draw the diagram. Okay, so let's start the innermost row. How many chairs are there? 7. And so there's probably 3 on one side, 1 in the middle, and 3 on the other side. So because it's a rainbow shape, it has to be symmetric. How many are in the next row? Okay, so if I have 1 in the middle, how many are going to be on each side of it? So 17, take away 1, 16, and how many then am I going to be able to draw on each side? So out of the 17, I've already drawn 1. How many do I have left to draw? 16, and if I need them equal on each side, 8. So I'm going to have 8 left to draw. Do you see the rainbowness of it? Did I miss? Oh, I went all the way to 17. Oh no, that makes me very sad. Like as a left brain, I'm really traumatized right now. No wonder you were all looking at me like that. Okay, how about we do row 2? Row 2, there are 12. So how many are there going to be evenly split? 6 and 6. How about now 17? $22. How many on each side? 11. If you're not visual, then don't worry about this diagram. You can just write out the pattern. The pattern is 7 followed by 12 followed by 17 followed by 22. Dot, dot, dot. B, keywords. Got my highlighter ready. Table of values. There's more that's important. It's telling you what the 2 rows have to be. The number of rows and number of chairs. So it's telling you what those rows in your table of values have to be. Number of rows, number of chairs. First row, how many chairs? Second row, how many chairs? Third row. Fourth row. Ooh, fifth row. Where's 27 coming from? So what are we adding to go from one to the next? plus 5, and then plus 5, and then, ooh, guess what our pattern is? So the 6th row has to have dot, dot, dot. Write an equation to show this relationship. Question doesn't say linear. Everything at this point is linear in your world. We need 2 variables and we need 2 numbers. First variable is going to represent number of chairs. Give me a good variable to represent chairs. C, sounds good. The other side of the variable has to represent the number of rows. Give me a variable to represent the number of rows. R. If you liked F from last time, use F. It doesn't matter what the variable is. Don't get caught up in what it means. We need 2 numbers. The first number is the pattern. What are we adding every single time? 5. The last number is just to balance. So if I do 1 times 5, I get 5. What do I need to do to get 7? Plus 2. Again, let's just check it. 2 times 5 is 10. How do I get 12? Plus 2. Questions on that equation, because that's the hardest part. D, verify there are 22 chairs in the 4th row. So it's great the table has told us, but let's actually verify. How do we verify? We just sub in. So number of chairs is 22. We want to indeed check that that's the 4th row. Multiplication first or addition first? Multiplication first. 5 times 4. 20 plus 2. What does this mean when you get 22 equals 22? It means you verified. Check, we're done. Yep, we proved it. How many chairs would be in the 7th row? Let's do this quickly because I want to get done before the bell goes. Chairs we don't know. What's going to go in for R? Multiplication first or addition first? Multiplication first. Waiting for you to tell me. 35 plus 2? 37. Whew. Homework is on the calendar.